Okay, and we'll start the class now. Okay, so now we'll start with the very basics. Now, let me start by telling you what is a network. What is a network? Okay, so now before even telling what is a network, yes, CCNA, right? Okay, without specs, I'm not able to see. Okay, so guys, yes, please. So let us start by telling what is a network. Okay, so network, any idea or anyone can guess what is a network? I know we have not yet started, but these are the basics, and yes, you guys know it, and that's why I'm asking questions. Okay, so without even reading these things, okay, I don't want you to read it now. Can you just let me know what is network? Or just casually?
Interconnection of clients.
Interconnection of clients, exactly. Or let me tell you, suppose I have got, say, I'm telling you that I got a friends network here. This is my friends network. It means I got some friends here, right? I have some friends here and my friends will be interacting. Okay, so similarly, now when you talk about the network here, we are talking about the computers or the devices or the machines. So the interconnection, or say the group of computers or devices interconnected to each other, is called a network. So you will have multiple computers here and at least 2 computers will be there. And you will interconnect these computers, forming a network. Okay, so that interconnection is called a network. So the process of creating a network is called networking. Okay, now you got components of a network. You have components of network. So if I tell you these are my friends, or this is my friends network, definitely we'll have friends, right? Similarly, if I say, or if I tell you that this is a network, definitely we got at least 2 devices should be there. Okay, so this is one device and this is another device, or in particular we will be talking about computers. So the components of a network, the first component is a computer. Okay, now the second component is called NIC. Have you heard of the term NIC? Yes, so you have already told the answer. Let me tell you again. So NIC here, it means network interface card. Network interface card. I presume you might have seen it. Let me show it to you. So this is an NIC and this is also an NIC. You might have seen at the back side of the computer. So you know the computer, right? So this is the CPU cabin. And to the back side of the CPU cabin, you might have noticed you will have different slots here, or ports. One such port is a USB port to which you can connect the USB pen drive or whatever it is. Or you can connect this mouse as well, right? Or you can connect the keyboard like that. So now among this port, let me again tell you, among this port, you will have one more port which is called NIC, network interface card. Okay, now, so to this, so you might have noticed, yes, please. Okay. You might have noticed, okay. Yes. So now you might have noticed in the backside of a computer something like this, a slot, a kind of port you might have noticed, right? It looks like this, and that is where you will connect the wires. You will connect the wires. If you have an internet connection, suppose if you have a computer, okay, and this computer is connected to internet. So you might have seen it. Okay, if you have a computer, you might be like, or you might have connected this computer to the modem, to a device called modem. Okay, or nowadays we call it as Wi-Fi router or wireless router. We have different names. Okay, so now let me tell you. So you will connect it to the NIC. Okay, so NIC is where you will connect, or NIC provides an interfacing section. It provides an interfacing section to connect to the network. Clear? Okay, so that is NIC, network interface card. That's the second component of the network. Okay, now the third component, media. The third component is media. Okay, media, you already know. I told you you would connect your computer using wire to the modem. So the media, or it is the medium through which you will send the data. Okay, so that means it is the wired medium, or say you can relate the medium to cables. Cable is a kind of wired medium. Okay, or some wireless media is also there nowadays, right? Wi-Fi or Bluetooth or whatever it is. Okay, so that is media. Getting it? Okay. Now, the fourth one is the connecting device. Connecting device. So now, let me take paint and let me just draw a figure. Suppose this is the computer and this is the CPU cabin. Okay. Now, the CPU cabin, the backside of the CPU cabin, I told you, you will have the NIC, which will be like this. Okay. Suppose it is the NIC. So now, suppose this is the first computer and this is the second computer, this is the third computer, and this is the fourth computer. Okay, now just a moment. Let me place the CPU cabin here. Now, so you got the first machine, the second machine, the third machine, and the fourth machine. Now, if I want to connect these computers, what I can do? So I can take a wire and I can connect from this first computer to the second computer, like this in the wired man. Now, if I want to connect the first computer to the third computer, so what I can do? I can place, or I can put another NIC here. I can insert another NIC. And here also, so I can connect it in a wired manner. Okay, again, if I want to connect from the third machine to the second machine, what I can do? I can insert another NIC here and another NIC here, and I can connect it like this. Right, again, 4 to 2. If I want to connect, so I'll again insert another NIC and connect like this. 3 to 4. Again, I'll insert 2 more NICs like this and will connect. You might be finding it difficult, right? So to connect 4 computers, now it's getting complicated, right? So now we are connecting it from one wire. So from one machine to another machine, we are connected it with wire. From this machine to this machine, wire again. So now it's getting complicated. Now, what if I want to send something from the first machine to fourth machine? Again, I'll have to connect or insert one more NIC, and here also I'll have to connect NIC, then again connect it like this. Okay, so it's now getting again complicated, right? So to avoid the complication, what I'm going to do is that I'll place a device. I'll place another device here. Okay, and this device is called connecting device. It's called connecting device. It can be many. There are many connecting devices. It can be hub, switch, etc. Okay, you will study about it later. Okay, now this is the connecting device, and the connecting device will have multiple interfaces. The connecting device will have multiple interfaces. So what you will do is that from the first machine, you will connect to the connecting device. To the second machine, you will connect again to the same connecting device. The same thing from the third machine also, you will connect to the connecting device, and the fourth machine also you will do, or you will connect it to a connecting device. So if I want to send something from first machine to the fourth machine, I can send it through this connecting device. If I want to send something from the first machine to the second machine, I can send through this connecting device. Without any complications, we have connected. So you got another requirement, which is the connecting device, which helps us to connect multiple devices. Clear? So these are the minimum requirements of a network. The first requirement is computer. Then in the computer, you have NIC, and media is required, and also connecting devices are also required. Okay, these are the minimum things you need to connect, or you need to, the requirements which you need for creating network. Okay, now we'll briefly talk about each component here. Okay, and before that, let me also tell you about the advantage of network. You already know the advantage of network, right? You have already been to internet cafes and all, right? Internet cafes, and you already, nowadays you already have smartphones and all. Okay, and let me again tell you, this smartphone, from this smartphone to another smartphone, you can send, say, the movies, you can send the files, you can send anything you want, right? So you can share the software resources, the movies, the files, the, like the PDF, whatever it is, these are the software resources. And you will share the hardware resources also. In the internet cafes, you might have noticed, you will have a printer. You will have a printer, and this printer is actually shared. If you have 10 computers in your internet cafe, what happens is that everything, say if I'm there in one machine, and if suppose say Vaman is there in second machine, he can also print it, and I can also print it, right? So the printer is shared here, so we can share the hardware resources, and you can implement security as well. You can implement security, means you can do something so that you can configure some configuration so that the first machine will communicate to the second machine, but the first machine will not communicate to the fourth machine. So thereby implementing security. Clear? So this is the advantage of network. Okay. Now we'll go to each requirement of the computer. Oh, sorry, each requirement of the network. Now the first requirement is computer. You already know about it. Still, we'll be discussing these relevant things. Okay, so the computer has got three parts. What are the three parts? Input device, output device, and also we got a CPU. Okay, central processing unit. Now, in addition to CPU, they also have another thing called memory unit. Memory unit. Okay, so if you want to save anything, it will be saved in the memory unit. Okay, now through the input devices, you will give the input. Suppose if you want to calculate something, you are taking the calculator, 1 + 1 = 2. You already know it, but still, if you want to check, say with the help of calculator, you will take the calculator and you will input 1 + 1. The basic things, right? Okay, through the input devices, which are the keyboard, say mouse, etc. Right. Now, the CPU will process it and will provide you with the information via the output device, via the monitor or via the printer. You will get the output device, sorry, output. Okay, now I told you, you got a separate section for memory for storing anything. Okay, now this memory is of two types. You already might have heard of it, this primary memory and the secondary memory. Okay, so primary memory is faster. Okay, and the primary memory, you have two types of primary memory. What are those things? RAM and ROM. RAM is random access memory and ROM is read-only memory. Okay, so RAM, let me tell you, it's random access memory. Okay, so whatever, say suppose I'm running some configurations, or I'm running, say suppose NFS, Need for Speed, I'm playing a game. Suppose I'm playing a car race game in my computer. So whatever that we are running, it will be there in the RAM. Okay, now it is, you guys already know these are, or the RAM is volatile in nature. If the power goes, then the values will go away, right? It will get erased. Okay, so RAM, and let me tell you, the important thing is RAM contains a running configuration. Whatever that we run, it will be there in the RAM. Clear? Now, the next thing, a ROM, a read-only memory. It's actually a chip. You might have noticed it's actually a chip in the motherboard. Okay, it's not really the hard disk. This ROM is a chip that you find it in this motherboard. Okay, now this ROM consists of many programs. So what we actually do is that at the time of manufacturing, we will burn certain programs into the ROM. We will burn some programs into the ROM. So, and one such program is called POST. It's called POST. You might have heard of it. Power on self-test. Power on self-test. So when you turn on the computer, what happens is that you might have seen this, the display will flash once, right? The display will flash once, and this thing, what do you say? This keyboard will also, like, the green lights will come and go, right? So these are the part of power on self-test or post. The computer, when you turn on the computer, the computer will check whether all the parts are present and all the parts are working or not. Clear? That is a process of post, power on self-test. Clear? Okay. Now, again, so that is the memory unit. And the CPU also consists of two parts. You already know it, right? So CPU, yes, ALU and CU. ALU, arithmetical and logical unit, which is responsible for arithmetical and logical calculations. And control unit, which controls all the peripherals, all the parts. Okay. So this is the two parts of CPU, ALU and CU. Now, let me ask you a question. Have you seen the CPU? Okay. So how does it look like, CPU? Sorry? It looks like a cabin and
holds all the components necessary.
holds all the components necessary. Okay, let me tell you. Okay, CPU, this is not really the CPU. This is called CPU cabin. It's called CPU cabin. Okay, where inside, when you check, you will have a motherboard. Okay, actually the CPU is the processor. It's the processor. Okay, it's not really this cabin. So this is the cabin which holds the motherboard. And in the motherboard, you will have a processor which is the CPU. Clear? Okay. Now, so this is the computer. And again, I suppose, so we have discussed about the primary, say in the memory unit, we have discussed about the primary memory, and also you got some secondary memory as well. So the example is hard disk. Hard disk and SSD are the examples of secondary memory. Clear? This is the computer. Okay. Now, the second requirement is NIC, network interface card. So I told you network interface card or NIC is used to connect to other devices, or it is used to connect to a network. Okay. Now, this NIC also consists of certain burnt-in programs. It also consists of certain burnt-in programs or certain burnt-in values, of which one value is called MAC address. It's called MAC address. I suppose you might have heard of this MAC address, right? Okay. MAC means media access control. Exactly. Media access control. That's the MAC. Okay. Now, so MAC address has got several names. First is called the burnt-in address. It's called the burnt-in address. Or it is also called MAC address. It is also called L2 address. It is also called hardware address. It is also called physical address. So the MAC address has got several different names. Okay. Burnt-in address, MAC address, L2 address, physical address, or the hardware address or physical address. Clear? Okay. Now, this MAC address, it's a 48-bit value. It's a 48-bit value. What is this bit, guys? Any idea what is bit? Exactly. So let me tell you, a bit means exactly binary digit. Okay, BIT. That's the bit. Okay, so you might have heard of binary digits, right? So what we humans use is the decimal digit. Okay, or the decimal number system. Just a moment, guys. Okay, so what humans use is the decimal number system. Decimal number system. You know it. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. But the computer use binary number system. Binary number system. So bi means 2. Means it consists of 0 and 1. That's it. It consists of 0 and 1. Okay. Now, so this is the binary. Now again, we got different number system, of which you need to study one more number system, which is called hexadecimal number system. Hexadecimal number system. So decimal system, number system has got 10. Dec means 10 numbers, 10. Okay, so you got 10 numbers. What are those 10 numbers? You already know it. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right. Okay. Now, again, if you want to write again, say 10, 11, 12, 13, but will be the repetition of these things. Okay. The repetition of these digits. Okay. Now, the binary number system goes like this. Okay. I'll tell you 0, 0, 0, 0, 0, 0, like that. Okay. So this will go like this 0, 0, 0, 1. This goes like this 0, 0, 1, 0. This goes like 0, 0, 1, 1. This is 0, 1, 0, 0. Okay. You might be wondering, you might be. Okay. Sometimes some students will be, say they have completed this one, say, what do you say? Computer science, and they know how to fill it. But if you have not completed the computer science, you may be wondering how we are writing this, right? Okay. So let me tell you how to write it. Okay. So here, decimal number system, you are adding 1 here. Every time you are adding 1. So 0 plus 1 will give you 1. And 1 plus 1 will give you 2. 2 plus 1 will give you 3. 3 plus 1 will give you 4. 4 plus 1 will give you 5. So every time we are adding ones. Okay. The same thing we are doing here. The same thing. Okay. So for that, to study that, let me first tell you about the binary addition. Binary addition. This thing, unfortunately, you will have to mug it up. But again, let me tell you, this is not a, say, hard thing and all. It's a very, very easy thing. Okay, you already know it. 0 plus 0. What is 0 plus 0? 0. If it's in binary or if it's in like a decimal, it is 0 only. Okay. And what is 0 plus 1? 1. Okay. So 1 plus 0. What is 1 plus 0? 1. Now, what is 1 plus 1? 0. 1. So whoever says 0, who are saying 0? 1, 2, 3, 4, 5. Only 5 people. So 5 people say 0. And how many people says it's 1? 1. You already raised your hands, right? Okay. 1. Okay. Only one guy says it's 1. And what about you guys? 2. Okay, let me tell you. So in the decimal format, 1 plus 1 is equal to, in the decimal that we humans use, what is 1 plus 1? 2. 1 plus 1 is equal to 2. But now in the binary addition, let me tell you, 1 plus 1 is not 0. It is not 1. 1 plus 1 is 0 with a carry 1. 0 with a carry 1. Okay. So you will have to mug up this one, only this one. 1 plus 1 is equal to 0 with a carry 1. It is similar to this one. If you write 9 plus 1 in decimal, what is 9 plus 1? 10. Guys, 9 plus 1? 10. Okay. So it means, see, it has reached its maximum. It has reached its maximum. Now this value has reset and the next value has come. Same thing. Okay. So here, this also 0 with a carry 1. Clear? Now we'll go back. So I suppose now you ought to remember this. You will remember this binary addition. We'll come back here. Okay. Now, I told you every time we will keep on adding 1. Right. So 0, the decimal value of, the binary value of 0 is 0, 0, 0, 0. You already know it. Right. So 0, 0, 0, 0. It's the 0 value. Okay, and plus 1, if I'm adding 1, what is the value? 0 plus 1 is 1. And this 0 will come here, this 0 will come here, and this 0 will also come here. And this value is this value, right? Now, again, I'm adding 1. Okay, so 1 plus 1, what is 1 plus 1? 0 with a carry 1, right? So you know 1 plus 1 is 0 with a carry 1. So 0 with a carry 1. Okay, so now we have a carry 1 and sorry, we have another 0 here. So 1 plus 0, what is 1 plus 0? 1. And this 0 will be written here and this 0 will also be written here. So 0, 0, 1, 0. So this is also 0, 0, 1, 0. Okay, now again I'm going to add 1. So this time 0 plus 1 is 1. I need more energy from you. Okay, so 1, this one will be written here and this 0 will be written here and this 0 will also be written here. So it is 0, 0, 1, 1. And now when I add again, so 0, 0, 1, 1. So this same value. Okay, plus 1. When I add this time, 1 plus 1 is
0.
exactly. Again, 1 plus 1 is
0.
yes, exactly. And 1 plus 0 is 1. And this 0 will be written here like that. So 0, 1, 0, 0. So this is how you will write down the values. Clear, guys? Okay. So now I want you guys to write down, or I want you guys to add these values like this. Keep on adding the values. Okay. Till you reach 1, 1, 1, 1. Okay. Till you reach 1, 1, 1, 1. Okay. So, or let me tell you, you need to write till this one. Okay. You need to keep on add in such a way that say 13, 14, 15. Okay, so you need to keep on add like that and need to find out the value up to 15. Can you do it, guys? Okay, yes, please carry on. Okay, guys, we'll wait for others to complete. And then we'll discuss it. Okay. Anyone finding it harder to do? Everyone able to do it easier? Okay. So then, even the online students, Kavya, Rakesh, Maunika, and Subhash, what about you guys? Rakesh has already told that it's done. What about others? Able to do it? Can't hear from you guys.
Yes, sir.
Okay. Okay, guys. Now, if you have done, we'll discuss it. Shall we? Everyone done? So if everyone's done, then no issues. Okay. So I thought of telling you an easier method and all. I suppose that's not necessary. Okay. So now, so this 5, you will get it like this: 0, 1, 0, 1. Then the next is 0, 1, 1, 0. 0, 1, 1, 1. 1, 0, 0, 0. Okay. Yes, the next one will be 1, 0, 0, 1. Exactly. 1, 0, 0, 1. And 1, 0, 1, 0. And this is 1, 0, 1, 1. This is 1, 1, 0, 0. And this is okay. And this is I can only hear 1, 1, 1, 1, 1. 1, 1, 1, 0. Okay. And the last one, what is it? 1, 1, 1, and 1. So this is how you will write it. Clear? Okay. So I suppose everyone is able to write it and you don't have any issues at all, because say we want these things and all. Okay, when we study one topic called subnetting, I want you guys to write it like this. So that's why I made you write it. And if at all anyone is feeling any issues in writing this, please let me know so that I can tell you an easy method. Okay, so now that you are okay with this method, I suppose there's no need to tell that easy method and all. Right? Okay. Now so this is the decimal and this is the binary number system. Now you got one more number system, which is hexadecimal number system. And you might know about this hexadecimal number system. Hexa means 6, hex or 6. Okay. Now dec means 10. So how many values you will have? 16 values you have. Okay. So total digits will be 16 digits. And you can say these digits are, let me tell you, zero to 9 and A to F. It consists of the decimal values 0 to 9, and then it consists of A to F. Means, let me tell you, so the value is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so up to 9 it's okay. And the next value, the value corresponding to 10, that value is A. Okay, and next value is B, C, E, D. Okay, yes, unfortunately I skipped D. So this is E and you have F. So if I tell you, if I tell you there is F or the value F, okay, that value in decimal, the value is 15. And in binary, the value is 1, 1, 1, 1. Clear, guys? So now my final thing. So this hexadecimal value corresponds to how many bits here? Corresponds to 4 bits. Corresponds to 4 bits. So one hexadecimal value corresponds to 4 bits. Okay. Now I told you that, coming back, about the MAC address. So the MAC address is a 48-bit value. It's a 48-bit value. We'll tell it's a 48-bit value, but we'll write it in hexadecimal format. We'll write it in hexadecimal format. So we need to convert this binary to hexadecimal. Okay, so now this hexadecimal is there. So now let me tell you, one hexadecimal corresponds to 4 bits. So 48 bits corresponds to 12 hexadecimal values. 48 bits corresponds to 12 hexadecimal values. So that means when I say MAC address is a 48-bit address, I will write 12 hexadecimal values. Clear? So that is how the MAC address is represented. Okay, now, so we'll write it like this. So this is how the MAC address is written. So let me write an example of MAC address. 1234, say ABCD A2B3. So I have written 12 hexadecimal values. Okay, and after each or after 4 hexa, you can write, I'll be like separating the 4 hexa using a dot. So this is the example of a MAC address. This is the example of a MAC address. Now, in some places, you can see like this: 1234:AB:CD:A2:B3. Like that also you can write. Okay, so you can group it into two hexadecimal values. Okay, but we'll be representing it like this: 1234.abcd.a2b3. Clear? So this is how a MAC address is written. Okay, now, so if you want to write the example of MAC address, you can write it down: 1234.abcd.a2b3. Okay, this is the example of a MAC address. Okay. Now, so this is 12 hexa values. Now let me tell you, this 12 hexadecimal value or this MAC address is divided into 2 portions. The MAC address is divided into 2 portions. So we will divide it like this. Okay, the first 6 hexadecimal value. The first 6 hexadecimal value or first 24 bits. Okay, it's called OUI. OUI, organizationally unique identifier. Organizationally unique identifier. OUI. Okay. So the first 24 bits is called, or it's called OUI, Organization Unique Identifier. And it is provided by IEEE. It's an organization, international organization, or I suppose it's International Electrical and Electronics Engineers, right? What is it? International Organization for Electrical and Electronic Engineers. Yeah, whatever. IEEE. You might have studied about IEEE, some papers and all, right? In the BTech, right? So here, so this is an international organization for electrical and electronic engineers. Okay. So now, the second part is called vendor assigned part. It's called vendor assigned part. Vendor assigned part. Okay. So now let me tell you what these things are. OUI. Okay. And vendor assigned. So now suppose I have a company named ABC Company. Okay. Where I manufacture computers or NIC or whatever. Then I will approach this IEEE. I will approach telling that I need an OUI value. Okay. And they're going to give me an OUI value. Organizationally unique identify. Suppose if I manufacture NICs, okay, then I'll approach the IEEE and I'll ask for OUI. And suppose they will give me an OUI. Say this is my OUI. Suppose, where is it? 000A A5B3. This is my OUI part. They will give me an OUI. Now, I will start manufacturing the NICs. Okay, and my NICs will be having this value as common. This is my organizationally unique identifier, or this is my value here. To identify my organization, this value, the first value is used, which is given by IEEE. And when I manufacture these NICs, my NICs will be having A5, sorry, not B3, up to A5 only, right? Okay, so you only have 6 hexa values up to here. Okay, so now the value will be like this, 000A A5. Okay, and the other value, suppose the NICs that I manufacture will have my own values here. Suppose some NICs will be having B3, say A2, B3, something like this. And another one will be having A5, say B4, C3, D5, like that. So this part or this OUI helps you to identify the organization. Clear? Okay. And this part is assigned by my own company, and that is why it's called vendor assigned part. Clear, guys? Okay. So this is the, sorry, NIC card, NIC card. Okay. Now, so coming back. So these things are already, I already mentioned these things. Now you can see this is the NIC. Okay, so this NIC, you can connect a wire here. You have the connection here, or you have the port or the interfacing section, you have it. And you can connect a wire to this NIC. Okay, whereas this one is the wireless NIC. It's wireless. They are having an antenna and they have a wireless. Okay, so this is the wired one and this is the wireless one. Okay, yes. Now, so this is the second requirement, which is called NIC or network interface card. Any doubts? Then the third, okay, before the third requirement, we'll go to some terms here. The first term is transmission type. It's called transmission type. Okay, so transmission type, you have two types. One is called broadband transmission and there is called baseband transmission. Okay, you might have heard of it, right? Broadband and baseband. So broadband means you are sending a signal in the analog format. So that is called broadband. And baseband means you are sending something in the digital format. That's the baseband. Okay, just some terms: transmission type, broadband, and baseband. Okay. Done. Now, the next one, transmission modes. Transmission modes. Okay. You have three transmission modes: simplex, half duplex, full duplex. Right. Simplex means one-way communication. It is one-way communication. One-way communication example is radio. So at the radio station, they are sending, and we will only be able to receive the signal. So that is one-way communication. So that is simplex. Now, half duplex, you can say walkie-talkie, right? So walkie-talkie, you can say if one person is sending something, if A is sending something, B will be receiving it. And afterwards, say when A stops, B can send. So that is half duplex. Duplex means, say, two-way communication, but non-simultaneous two-way communication. That is half duplex. Okay. Now, full duplex, you already know it is at the same time you can transmit and you can receive. So that is simultaneous two-way communication. That is full duplex. You might have heard of it and you might have studied in BTech or BE or whatever it is. You might have studied in depth related to these things and all, right? So consider these as just the brush up things. That's it. Okay. So this is the transmission modes. Okay. Now you got one more term which is called transmission methods. Transmission methods. Transmission methods. The first is called unicast. Unicast transmission. That is one-to-one transmission from one machine to single machine. That is one-to-one transmission. That is called unicast transmission. Okay. Now the second one is called multicast transmission. One to many. One to many. M-A-N-Y, many. Or one to a group, you can say. One to a group. Okay. Now, broadcast means one to all. One to all. Or one to everyone in that network. So that is broadcast. And one more is there. Not in every case you will find it, but only in some cases you will find it. That is called anycast. Anycast. It is one to nearest. It's called one to nearest communication. One to nearest communication. That's the fourth one, anycast. Yeah. So that is there only in some cases, not in every case. Okay. Now, these are the transmission methods. Okay. Now, shall we go to media, the third requirement? Okay. Now, media. So it is the medium through which the data or information is sent. You already know it, right? So it is the medium through which the data or information is sent. You got two types. One is wired and the other is wireless, or bounded media and unbounded media. Okay. Now, bounded media, you got many examples here. The first one is, say, I told you bounded media are cables or wired media. So those are cables. And the first one is coaxial cable. First one is called coaxial cable. You may not write it. So guys, let me again tell you, these are just the very, very, very basic things. Okay. So these will not be asked in any, like, it's most probably they'll not be asking. They'll not ask you. It's that these are the very basic things and all. Okay. So you can just listen. Nobody is going to ask what is this coaxial cable, what is the structure of the coaxial cable, what. But some questions you can expect. Okay, some questions may be like what is the bandwidth, or such questions you can expect. But that too will be asked in the very, very basic things. So we actually have a lot to study. So these are just, I have mentioned it so that you will get an overview of everything. That's it. Okay, so now media, bounded media. So we'll first study about coaxial cables. Okay, and next we have something called twisted pair cables. And the third you have optical fiber cables. Okay, so the coaxial cable, let me show it to you, the coaxial cable. This is the structure of the coaxial cable. You might have seen it. Okay, so you got a black insulator jacket, and if at all you have, say, like opened it or you have cut it, you might have noticed the shielding wire mesh. Then inside you have some dielectric material, and inside you have a copper core. Okay, this is the structure of the coaxial cable, and you might have noticed it in the cable TVs on those connections and all. Right. So this is the coaxial cable. Okay. Now the next one. And again, so again, let me tell you, the coaxial cable can be divided into two. It can be divided into two. Broadband coaxial cable and baseband coaxial cable. Broadband coaxial cable and baseband coaxial cable. Now, this baseband coaxial cable is again divided into two. It's called thick net and thin net. Thick net means it has thick shielding. You can see in the figure it has thick shielding. But thin net doesn't have much shielding there. It only has some thin shieldings will be there. Okay. Now, the transmission type, both are baseband transmission. Both are types of baseband coaxial cables. Okay. Now, the maximum bandwidth. Sorry, guys. So the maximum bandwidth is 10 Mbps. The maximum bandwidth is 10 Mbps. Okay. And you might be wondering what this is, 10 base 5 and 10 base 2. I'll tell you. Okay. But before that, let me tell you, the maximum length is 500 meters and for thin net, it is 185 meters. Okay. So it means you can lay a cable. If it's a thick net cable, you can continuously lay the cable up to 500 meters, maximum up to 500 meters. This is maximum up to 185 meters. Okay. Now, let me tell you what it is. 10 base 5 or 10 base 2. Okay. Or you might hear, maybe later you might hear 10 base T or 100 base T or 1000 base LX. Like that you may hear. So this 10 or 100 or 1000, these things are called, these are the bandwidth. These are the bandwidth. So here it's 10 Mbps. Here it is 100 Mbps. Here it is 1000 Mbps bandwidth. Now, this is the transmission type, whether it's broadband or baseband. These are the baseband. So it's base. Okay. Now, here 5 and 2, it simplifies or say it signifies the length of the cable. The maximum, it can be used up to 500 meter. So here it can be say around 200 meter. Okay. In some cases where you see alphabet, it says the type of cable. So T here, it means twisted pair cable or unshielded twisted pair cable. Okay. This LX, I suppose it might be optical fiber cable. Okay. So this alphabet here at the last, it tells you the type of cable. Clear? So this is how it is. 10 base. So if at all you come across 10 base or 100 base LX or 1000 base LX, you should remember what it is. Clear? Okay. Now, say if this is a cable, you will connect it to a connector, and it can be also connected to a port as well. So here the connector is called vampire type connector, and the port is called attachment unit interface. Just understand these, understand these things. That's it. Again, here thin net, you have connector, BNC connector, and the port is BNC port. An application of thick net is cable network, LAN connection, etc. And thin net, it's thin base LAN cables. Okay, thin base LANs, which is normally not seen nowadays. Okay, so this is the coaxial cable. Okay, now the next one, twisted pair cable. The next one is called twisted pair cable. Okay, so twisted pair cable, let me tell you, you got two types. One is called shielded twisted pair. You can guess it. So again, the advantage in the networking is that whenever you hear a name, you can guess it and it's going to be right only. Probably it's going to be right. Okay, so you can guess when you hear about shielded twisted pair, you can guess what is this shielded. It means you have thick shielding. Okay, so here you can see you have an outer shielding. Inside you can see a mesh. Okay, and inside you can see again, you can see an aluminum foil. Then later you can see some cables inside or some wires inside. So here it is shielded. Okay, and the unshielded twisted pair, you can see this is not at all shielded. You just have a plastic coating, and inside this plastic coating you can see the wires. Clear? Okay, and let me take the magnifier here. So here, let me show you. So that is shielded and unshielded. Now coming to the next one, twisted pair. So you can see here, you got 4 pairs of wires here, 4 pairs. The first one is the green pair. You can see this is the green one. Okay, green, and you have one more wire, which is the white wire. So this is the green pair. and it is twisted. These pairs are twisted, and that is why it's called twisted pair. Now you have another one, brown pair. You can see the brown, and along with that you can see a white one. Okay, and then you can see the blue one, and you can see the twisted white one along with it. Now you can see the orange one. Along with that, again you have twisted white one. Clear? Sorry. So this is the unshielded twisted pair cable. And again, let me tell you. So here, how many wires are there? Total 8 wires are there. 8 wires, or 4 pairs of wires. 4 pairs of wires. Okay. So here, if I tell you you got 4 pairs of wires or 8 wires, we can name all these 8 wires. We can name all these 8 wires. So the green pair, I told you, you got a green cable here or a green wire here. And that wire is called green. It's called green. And along with green, you can see a white wire which is twisted, right? And that is called white green. It's called white green. Now, brown, right? So here you have a brown wire and you have white brown. Okay. Now you can see a blue pair, and this is the blue wire. Okay. So this is the blue one. And along with that, a white is twisted. So that is called white. Guys, I need to say response. White, blue. And what about the orange pair? Orange and white orange. So this is how you will name it. Clear? Okay. So this is the naming of the wires. Okay. So you can write it down, and then we'll take a small break. What's the time now, guys? 6:30, 35. Okay. So then we'll take a small break. We'll get back at 6:30, sorry, 6:40 or 6:41 p.m. I suppose 5 minutes break is sufficient for you, right? Okay. So you can write down the name of these wires and then take a small break. Just a moment. Just a moment, guys. in the watch as well. So guys, I suppose I should have paused it. Okay. And what was the last thing that I told you about the wires only, right? So we were talking about, yes, twisted pair. Now, so unshielded, so I suppose I've started recording. Yes. Now, this unshielded twisted pair, you got different categories. Okay. So if at all you are working guys, or if at all you are a working class, you might have heard of it. Okay. So you might have heard of Cat 1, Cat means category. Okay. Category 1, category 2, Cat 3, Cat 4, Cat 5, Cat 5e, Cat 6, Cat 7. Like that, you have different categories. Okay. Now, Cat 1 is broadband. And the bandwidth here is less than 1 Mbps. And the maximum length everywhere, the maximum length is 100 meter only. So we can use a maximum up to 100 meter. These cables are called twisted pair cables, or it is also called LAN cables. The working class, they might be familiar with this name, LAN cable. Okay. Or again, it is called with another name called Ethernet cable. It's called Ethernet cable. Okay, so you got different names here. So UTP or LAN cable or Ethernet cable. So everything refers to only single cable here. Now, so the category 1 cable, say the bandwidth is less than 1 Mbps. And category 2, you can see it's 4 pairs of wires and these are baseband. Everything here is baseband. And the difference is that it has got 4 Mbps bandwidth. And the Cat 3 has got 10 Mbps bandwidth. Cat 4 has got 16 Mbps. This is 16 Mbps. And Cat 5, 100 Mbps. Cat 5e, 1000 Mbps. Cat 6 also 1000 Mbps. And Cat 7, 10 Gbps. This is the bandwidth. Okay. If you are a working class, you might have seen the Cat 6 cables or the Cat 5e cables, which were used till now. Okay. Now they might have started using this Cat 7 cable as well. Yeah. So these are the category UTP categories. Okay. Now, so I told you, you got 8 wires. You got 8 wires. Now, so again, this is the, now let me tell you, this is the wire. This is the wire. Now you got 8 wires here. 1, 2, 3, 4, 5, 6, 7, 8. These 8 wires can be arranged in a particular order. These wires can be arranged in certain particular order. Okay. So arranging the cables in a particular order and connecting it to the connector and punching. And this process is called crimping. It's called crimping. So arranging the cable and connecting it to the connector is called crimping. Okay. So for crimping, you will arrange the cables. So arrangements are done in 2 ways. Arrangements are done in 2 ways. So, or it's called crimping standards. It's called crimping standards. So you got 2 standards, 568A standard and 568B standard. In 568A standard, in 568A standard, you can see the first wire is white green. The first wire is white green. And the second, so let me write it here. I'll write it in the paint. Okay. Just give me a moment. So it's 568A standard. The first wire is white green. Okay. The second is green. And the third is white orange. And the fourth is white, sorry. The fourth is, any guesses what the fourth is? No, it's not orange, it's blue. Okay, so blue. Now, okay, I'll tell you. Okay, so this one is white blue. And next one, this orange comes here. Okay, so you have to remember 1, 2, 3, and 6 pins. 1, 2, 3, and 6 pins, which are important. So now the 7th pin here, this one is white brown. And the 8th one is brown. So this is the 568A standard. White green, green, white orange, blue, white blue, orange, white brown, and brown. Clear, guys? Okay. None. Okay. Yes. Now we'll study 568B standard. In 568B, let me tell you, the difference is that wherever the green comes, the green will change to orange. Okay, the green one will change to orange and the orange will change to green. That's the difference. Means the difference will be in 1, 2, 3, and 6 pins. The others will be same. Okay, so now let me tell you, the first one will be white, orange. Okay, now the second one will be orange. And the third one will be white, green. Exactly. The fourth one will remain the same. Fourth, fifth, and all will remain the same though. So the fourth will be blue and fifth will be white, blue. And the sixth one will be green. Okay. And the seventh one will be white, brown. And the eighth one will be brown. So here again, 1, 2, 3, and 6th pin will change, whereas the other 4 will remain the same. Okay. So this is the crimping standard, 568A standard and 568B standard. Okay. Now, okay. And guys, again, I told you that I don't have my phone with me now, not my watch. So if at all it's around 7:30, by around 7:30, let me know, or else I'll keep on continuing lecture. Okay. So just let me know when it's time. Okay. So now, so this is the 568A standard and 568B standard. Now, guys, so suppose this is a wire. This is a wire. The wire will have 2 ends. Right, definitely the wire will have 2 ends. Now, you can arrange or you can crimp 568A standard here. Okay, you can crimp 568A standard here. And you can crimp 568A standard here as well. Or you can crimp 568B here and you can crimp 568B here. If you crimp the same standards on both the ends, then that is called straight through cable. The cable is called straight through cable. Straight through cable. Straight through cable. Straight through cable. Okay, you are crimping, the both ends will be same. 568B, 568B, 568A, 568A. Both the side will be same crimp. Okay, now, so you can see, and let me again tell you why it is called straight through. So suppose you are crimping 568B and 568B at both ends. So if you are crimping 568B standard, what will be the arrangement? The arrangement will be, first will be white orange, orange, white green, blue, white blue, green, white brown, and brown. The same standard will come here. Okay, that means the first wire, which is white orange, will be coming as the first wire here. Okay, so this is white orange here, and the second orange will be coming as the second one here. So orange, and the third one white green will be coming here, and blue, white blue. So you can see the wires are going straight, and that's why it's called straight through cable. Clear? Okay. Now the next type is called crossover cable. It's called crossover cable. You can obviously guess. Crossover means, say, you will crimp 568B in one end, and at the other end, you will crimp 568A. Okay, so here you can see 568B is there, and 568A is there. And when you crimp 568B, the first wire is white, orange, orange, then the third is white green, and sixth one is green. Okay, so now when you crimp the 568A at the other end, the first cable will be, or the first wire will be white green, then the second will be green, then white orange, orange. So now let me tell you, the first white orange will be going from the first pin to the third pin. So 1 is connected to 3. Then second one is connected to the sixth one. Okay, so 2 is connected to 6. And the third one is connected to the first one. And the sixth one is connected to the second one. So this is the crossover. And that's why it's called cross, right? It's like in a crisscross manner. Okay, so that's why it's called crossover cable. Guys, again, I'll be sharing the PPT to you. Okay, you don't need to draw this thing. I'll be sharing the PPT. I suppose I have already shared it. Okay, usually I'll be sharing the first 2 PowerPoint. Okay, you can check it, and I might have already shared it. So I'll add you to the group as I told you. Okay. Now, so this is the crossover cable, and you have one more thing called rollover cable. It's called rollover cable. So rollover cable, you will crimp one standard here. It can be 568A or can be 568B. So here I have written 568B here. Okay, if it's 568B in one end, then the other end will be having the opposite or the reverse of 568B. It'll just be the reverse. So, or you can say it is as if I have just rolled it. Okay, so when you roll it, say I've just rolled it. So that means whatever is coming first will be coming as the last here. Okay, so 1 is connected to 7 and 2 is connected to, sorry, 1 is connected to 8, 2 is connected to 7, 3 is connected to 6, and so on. Clear? So this is the rollover cable. Okay, now. So that's the optical, sorry, that's the, yes, twisted pair cable. Twisted pair cable. Clear? Now, guys, now we'll study the optical fiber cables. We'll study the optical fiber cables. Okay, so now optical fiber cables, you might have heard of it, right? So what we are going to do is that, so this optical fiber cable consists of 2 parts. Let me tell you. The inner part is called the core, right? And the outer part is called the cladding. Core and cladding. Okay, so now optical means light, right? So you will be converting this electrical energy to, say, light rays. Okay, sometimes it will be in the visible range, sometimes it will be in the, say, non-visible, or say some other range. Okay, so now what we will do is that we will send these light rays through the core. Okay, and it will get reflected. It will get reflected. Okay, and the light get traversed due to a property called total internal reflection and all. We are not going into those things. So you might have studied it in the science, right? Okay, the lower, say, lower class science and all, physics or something. So now the point here is that you are sending it as light rays. Okay, so that is why it's called optical fiber cable. Okay, now you got 2 types of optical fiber cable. The first is called multi-mode and the other is called single mode. In multi-mode, you will pass multiple light rays. You will pass multiple light rays like this. In single mode, you will be passing only a single light ray. The single light ray will get reflected like this. Will get reflected like this and will be reaching the other end. And single mode is preferred for long distance communication over multi-mode. For long distance communication, we will prefer the single mode optical fiber cables. Now, talking about the types of optical fiber, there are different types or different grades of optical fiber cables. I have not mentioned it because you got, say, starting from the very small to, say, suppose you can use it in the, say, underwater sea cables. You can use it to connect to the other continents. So there are a lot of like optical fiber cables. So that's why I didn't mention any type of optical fiber cable. Clear? Okay. So this optical fiber is also called OFC. So if at all you hear OFC, then understand it's optical fiber cable. Clear? Okay. So these are the cabling part. I suppose you are okay with the cabling part, right? Okay. Now we'll go to the fourth requirement, which are the connecting devices. So you can write the connecting devices. Am I going fast? Right. Now, we'll first talk about hub. So you can write hub. Now, let me tell you, hub has different properties. The first property is signal regeneration. It's called signal regeneration. Okay. Signal regeneration means, suppose this is the connecting device hub. Okay. And we have connected from one computer to another computer you are connected. So I told you, if you are using the Ethernet cables or the twisted pair cables, the twisted pair cables support maximum up to 100 meters. Okay, so if at all you are sending something and that is far away, suppose it is like 90 meters away. The problem is that whatever you send the signal, there are chances that it will get distorted. Okay, the chances that it will get distorted, or the power, it will say there will be a power difference or the power will be down. Okay, so you need to make it back, or you need to like, yes, boost it. The exact term is to boost it. So the process of boosting the signal is called signal regeneration. Clear? Okay. Now, another thing is that the hub is a physical layer device. It's a physical layer device. We haven't talked about any layers yet. Okay, so just understand it's a physical layer device. When we study one topic called OSI, we'll talk about the layers and all. Okay, later we'll talk about these things. Okay, now the hub has got fewer number of ports. The hub has got fewer number of ports. So you can see here, say this is a hub. If at all it's a hub, 1, 2, 3, 4, 5, 6, 7, 8. Only 8 ports are there, or maximum it can be up to 16 ports, something. Okay, so the hub has got only fewer number of ports. Now, the disadvantage of hub. So nowadays we are not using the hub. Let me tell you why. There are many things here. The first thing is signal broadcasting. Signal broadcasting. So now let me take paint. I suppose. Yes. Okay. So this is the old figure that I've drawn. Suppose this is hub. Suppose this is hub. Okay. Now, if you're sending something from the first machine to the fourth machine, 1 to the 4. If you're sending something, you will send it to the hub. And hub has got a very, say, disturbing property here, which is called broadcasting, signal broadcasting. It means if something is sent to the hub, it will broadcast to everyone. It will broadcast to everyone. It will be sent to the machine, second machine, it will be sent to the third machine, it will be sent to the fourth machine, and it will be sent back to the first machine also. Clear? It will send back to all the interfaces, including the source interface. That is the property of the hub. That is called signal broadcasting. Okay, so the problem with the signal broadcasting is that, say, it may result in collision. It may result in collision. Okay, Now, so again, another disadvantage. So here, suppose you got 100 Mbps connection here. 100 Mbps connection is coming. Okay. Now, if you got only two machines, this bandwidth, which is 100 Mbps, which it will get divided into two. It will get divided into two. If you have four machines, it will get divided, or it will be shared into four. So bandwidth sharing will take place. Or you can say the hub, it doesn't have a specific bandwidth, or it doesn't have specific bandwidth in its interfaces. Okay, the bandwidth will be shared to all the interfaces here. Clear, guys? Okay, so that is another property of the hub. Okay, so and again, let me tell you one more thing. Hub is actually a non-intelligent device. Hub is actually a non-intelligent device. Okay, it means, so now let me tell you an example here. So this is myself. Okay, now I know, so here we have, let me tell your name, don't tell your name, Vaman. Okay, so we got Vaman in front of me, right? And we got, again, don't tell your name. Okay, tell your name. Yeah. Deva. Okay, so Deva is there. Okay, and I suppose you are, we didn't meet yesterday, is it? Sorry? We met. Salman. Okay, so we met. Okay, so Salman. So we got Salman to my right side. So suppose I'm an intelligent guy, right? So I know to my right side, I got Salman here. To my left side, I got Deva. To my straight, I got Vaman. Right. So you can call me as an intelligent guy. But here, if it's a hub, he doesn't know here to his left side, the first machine is sitting. He doesn't take care of that, or he doesn't think about it. Okay. Or he doesn't keep track of it. Okay. To his right side, the second machine is sitting. He'll not keep track of it. And that is why he'll be sending it to everyone. He doesn't know where these machines are sitting. So whenever he gets something, he'll send it to everyone. That's the problem. So you can say hub is a non-intelligent device. Hub is a non-intelligent device. Clear, guys? Okay. So that is again another disadvantage. Okay. So these are the reasons why we don't use hub nowadays. But still, in the production, maybe in the small level, you can see hub are still being used. Okay, maybe in the small places and all, we might, or we can notice it. Okay, now, so this is the hub. So signal regeneration, it's a physical layer device, fewer number of ports, and disadvantages, signal broadcasting and bandwidth sharing. Okay, now the next device, the next connecting device, which is called switch. So instead of hub, we are using switch nowadays. Instead of hub, we are using switch. Sorry. So now let me tell you about switch. The first thing, just understand this, it operates in data link layer. It operates in data link layer, or it operates in layer 2. It operates in layer 2. Okay. Now, the next thing is that the switch has got multiple ports. It has got different or multiple ports will be there. That depends upon the switch model. Sometimes the switch may have 100 ports even, or 100 interfaces. Okay, so that depends upon the model. Say you may have 24 port switch, you may have 48 port switch, you may have 96 port switch. That depends upon the model. Okay, so the switch can have multiple ports or multiple interfaces. Okay, the exact word is interfaces. Okay, now the switch again, it performs signal regeneration. The same thing what this like hub does. Okay, now the switch again, the positive or the plus things of the switch are it doesn't broadcast unnecessarily. No unnecessary broadcast will be there. It broadcasts only if it's necessary. Okay, so now no unnecessary broadcast. And if at all it broadcasts, Now let me tell you. So suppose this is switch here. Sorry. This is switch. So suppose if this is a switch, and if the first machine is sending something to the fourth machine, if the first machine is sending something to the fourth machine, so it will send to the switch. And switch, what he will do is that if at all he needs to broadcast, he will send it to the second machine, he'll send it to the third machine, he'll send it to the fourth machine also. But he will not send it back to the source interface. To the first machine, he will not send it back. And this process of broadcasting or sending it to all the interfaces, excluding the source interface, this process is called flooding. It's called flooding. Clear? So switch will perform. The first thing is that switch will perform broadcast only if it's necessary. And it will perform broadcast, but it will not send it back to the source interface. So you can say switch performs flooding when necessary. Clear? It performs flooding. Okay. Yes. So that is one thing about the switch. No unnecessary broadcast, and say when required, it performs signal flooding. And the next thing is that switch is an intelligent device. It's an intelligent device. Okay, so now let me tell you. So switch knows where these machines are sitting. Switch knows to the left side, to the left upper side, machine 1 is sitting here, and to the right upper side, machine 2 is sitting, and to the lower left side, machine 3 is sitting, and to the lower right side, machine 4 is sitting. So switch is an intelligent device. It keeps track of where the devices are sitting. Clear? Okay. So this is the, again, the next property of the switch. It's an intelligent device. And very, very important thing is that switch consists of a hardware part. It consists of a hardware part, which is called ASIC. It's called ASIC or switch engine. And the full form is application specific integrated circuit. Means it has got a space, or it has got a, you can say, a dedicated hardware. It has got a dedicated hardware for switching purpose or for forwarding purpose. And that is why we use switch nowadays, because we got dedicated hardware here for its working. Clear? So this is the switch. Okay. Yes. The next thing. Okay. The next device is router. Okay. Shall I? Okay. So now, suppose this is our classroom. This is our classroom. Now, this classroom has got multiple machines here. It has got multiple machines. And you can interconnect these machines with a switch. You can interconnect these machines with a switch. So from these computers, say, suppose the computer will be having NIC, and from this NIC, I'm connecting it to the switch. And they can communicate with each other. Okay. Now, suppose we got another classroom. Suppose this classroom. Okay. So that classroom has got some other computers here. Another set of computers. And what you're going to do to interconnect those computers, you will again connect it to another switch. So now this is our classroom, CCNA classroom. And suppose that is CCNP classroom. Okay, CCNP classroom. So this is in one network, or it is in one classroom, or you can say it's in one network. And this is in another classroom, or you can say this is in another network. So this is network 1. Network 1, and this is network 2. So you got 2 networks here. To connect these 2 networks, you're gonna have a router. You will have a router to connect multiple networks. So the router will also have interfaces. It will minimum, or it needs to have minimum 2 interfaces so that 2 networks can be connected. Okay, so one interface will be connected to this switch and the another interface will be connected to this switch. Okay, so the router is a device which helps you to connect multiple networks, or you can say multiple networks are connected by using a router. Clear? Okay, so the same thing here. Say here, leave the first thing, just understand it operates in network layer or layer 3. Okay, you'll study later. Now, router connects different network. So it must consist of minimum 2 interfaces. So this is the router here. Okay, for all the offline guys, this is the router. Okay, this thing is the router. Okay, so for all the online guys or whoever it is, so the same thing. I've just shown this thing, this device. This is the router. And you can see this is the symbol of the router. This is how we'll represent the router. Okay. Yes, just a moment, guys. Okay. So now, okay. So then the next device. Okay. Next device, you got many devices here. Firewall. I'm pretty sure that you might have heard of firewall, right? So after all, you are using computer and you might know that the computer has got a firewall. Okay. So the computer firewall, so let me first tell you what is a firewall. The firewall, it can be a device or a software. It can be a device or a software. And this software, what the software will do is that he will block the unnecessary traffic. Whatever it's unnecessary, he'll just block it. Okay. And whatever it's necessary, he will allow it to pass. And whatever it's unnecessary, he'll block it. Okay. So that's the firewall. It's a security device. It monitors the incoming and outgoing network traffic and decides whether to allow or block. Clear? So this is the firewall. And again, I told you, your computer is having a software firewall. Okay. In the production environment or in the company environment, you have a separate device itself. You have a separate device. Okay. Now, the next thing, intrusion detection system. Intrusion detection system, or it's called IDS. You have lot of networking devices. We'll just say, I'll just cut short it and we'll be telling you these basic things or the basic devices. So intrusion detection system, it's a security device which checks the intrusion. It will detect the intrusion. That's it. In case of any intrusion, it will detect it and let us know. That's it. Okay. Now you got another device called intrusion prevention system, or it's called IPS. Okay. It will detect and will also prevent the intrusion. It will detect as well as it will prevent the intrusion. Okay. And another device, modem. It is familiar to you. Right. So modem performs modulation and demodulation. It performs modulation and demodulation. So that is modem. Okay. So these are the network devices. Okay. Now we'll go to some other devices as well. Endpoint devices. It's called endpoint devices. So endpoint device, you got many devices. Example, you. Okay. So one machine is the laptop. Just a moment, guys. Yes. Just a moment, guys. So guys, now endpoint devices. So endpoint device, you got, say, the edge devices or the end devices, which are the laptop, desktop, mobile devices, etc. Okay. Now, again, you got another endpoint device which is called server. Okay. Server is nothing but a powerful machine. It is just a powerful machine or a powerful computer with greater physical, say, requirements or greater physical specifications. Suppose you got 64 GB RAM or 128 GB RAM or 500 GB RAM. They got greater spec. Okay, so these are devices. These are powerful devices with greater specifications. And these devices provide us with certain services. These devices provide us with certain services. Clear? So now let me tell you some example of servers. Okay, you might have heard of, I'm not sure, if at all you were working or if at all you are working, you might have heard of a server called DHCP server. DHCP. Okay, we'll study more about DHCP, but let me just tell you briefly about it. Okay, so now for communication between humans, we have names, right? So myself, I'm Bharat, and suppose we got Deva here. Okay, so if I want to tell something to Deva, I'll call him, hello Deva, and I'll talk to him, right? So I'm calling him, or this is his name, or with a name we can address him. Similarly, for the computers, the computer has got it doesn't have any name, but it has got certain addresses. One such address is the MAC address. MAC address. So this has got, the computer one has got a MAC address, and this computer two has also got a MAC address. And another such address, you have something called IP address. You have something called IP address. So the computer one will also have an IP address, and the computer two will also have an IP address. Okay, so for communication, we'll be utilizing these IP addresses. Okay, later I'll tell you the difference between MAC address and IP address and all, but now we are not going to go into that. So this computer one will have an IP. Suppose the computer one has an IP address IP1 and computer two has an IP2. For every communication. So if you have a laptop, if you have a mobile phone, if you are trying to communicate, say to WhatsApp or Facebook, whatever it is, this IP address is required. But have you set an IP address? Not to working guys? Okay, to the freshers, just asking you a question. Have you ever set an IP address? No, I suppose. Okay, it means the IP address, you have not set it, but it will get an IP address from a server called the DHCP server. So the DHCP server provides the computer with an IP address. Clear? Okay, so DHCP means Dynamic Host Configuration Protocol. So that's the DHCP server. Okay, and the next thing, DNS server. DNS server. When you type www.google.com, we know this address, www.google.com or www.facebook.com. We know it, but the computers doesn't know it. Computers, again, I told you it works on the IP address. Okay, so when I do some Google search, actually what happens is that this www.google.com, or this is called domain name. It's called domain name. This domain name should be converted to the IP address. It should be converted to the IP address. So this server, DNS server, will convert this google.com, www.google.com to the IP address and back. So the server which converts the domain name to IP and back is called the DNS server or the domain name server. Clear? Okay. And again, one more thing. This is very simple or very interesting. Windows deployment server, or it's called WDS server. Okay. Now, suppose you are working as a network admin, or suppose as working as a system admin or a desktop support. Okay, or system admin, suppose. Say in this company or in this organization, they bought 1,000 machines. They bought 1,000 machines or 1,000 desktop they bought. Now, as a system admin or as a, say, like server admin or whatever it is, okay, you need to install the operating system, the Windows operating system in all the 1,000 desktop or all the 1,000 PCs, right? So what will we do? What will we do? We'll be taking, or we'll be having a CD, right? Most probably previously we were using a CD. Now that you can use a USB drive. right? You can use it a USB drive. You can make it as a bootable one, and you will insert it to the first computer. You will install it manually. Again, you will install it to a second computer. You will install it to a third computer, fourth, 5, 6, 7. Maybe you will install to maximum, suppose 50 computers, and you will sit like this, right? What will you do? That is where this WDS server will help you. Okay, so this WDS server, if it is installed or if it is configured, then it will automatically deploy the operating system to all the machines. You don't have to do anything. You just have to connect these machines together. That's it. Okay, and it will deploy the operating system, or it will push the operating system to all these machines. So that is Windows Deployment Server. Clear? Okay. Now, again, FTP server, file transfer protocol. Okay, so again, let me tell you an example. Say, suppose you are working in a company. Say, when you go to the company, and when you are, say, suppose you are just newly recruited by the company, then they will be like giving you the training and whatever it's required for your work. They will be giving you the training. Suppose they'll be telling or giving you a site, or they'll be like giving you some videos, and they'll be asking you to download the videos, the training videos. Instead of taking it, they'll ask you to download the videos and study yourself. So the videos or those things, the files and everything will be saved to a machine called FTP server. From this FTP server, you can transfer the files, file transfer protocol. Okay, so you can save your files and folders, your everything you can save to a server called FTP server, and you can retrieve it back. So that is the FTP server. Clear? So again, you have lot of servers, but these are the basic things. Clear, guys? Okay, so these are the devices. So we have studied, say, the connecting devices now, right? And connecting devices, and also the endpoint devices as well. Clear? Any doubt so far? So what's the time now? 7:25. 5 minutes more, right? Okay. So not gonna take it now. Okay, so now, let me take a small portion here, then we'll wind up. Okay, or what do you say? Do we want to study more, or shall I wind up? What do you guys say? I'll leave it for you guys to choose. Yes or no? Yes to study, or yes for leaving? Study. Okay, so we'll study. Any difference in opinion? No. Okay, then we'll go. So now, guys, don't want to waste the time. So these things and all we'll go with tomorrow. Now I'm going to teach you. So this is the typical Soho network. It's the typical Soho, means small office, home office. Small office, home office. Okay, so it means the typical home network. That's it. Okay, now suppose we got computers, or the small office type. Suppose where you have, say, if you want, you can turn off the AC. Okay, so now suppose you got, say, 10 to 20 machines or something maximum. Okay, I thought somebody was like looking at the AC and they want to turn it off. Okay, now, so suppose you got 20 machines and all, or 20 PCs. So these PCs here, you got PC here, workstation, laptop, PDA, phone, whatever it is. You can connect it to the switch. You can connect all these devices to the switch first. So these are the wired network. These are the wired network. Now, what if you want to connect the wireless laptops or wireless, say the mobile phones, you can connect it wirelessly. So now these wireless devices can be connected. How it can be connected? So it will be connected to a device called access point. It will be connected to a device called access point, which will be like something you already know. It is called a hotspot. You might have like turned on the hotspot if you're mobile. You might have like turned on the Wi-Fi, right? So the hotspot, what he will do is that he will transmit some signals, some electromagnetic waves he will transmit. So it is similar. So this access point is similar to the hotspot. So what we will do is that we will turn on the Wi-Fi in the laptop and we'll connect to this Wi-Fi. So we'll connect to this Wi-Fi and then it will get connected to the wired network, to the switch. That means to the wired network. Clear? So these machines, including the server, PCs, or whatever it is, so everything now are connected. And then we'll connect it to the firewall. Then we'll connect it to the router. Then from the router, it is then sent to the internet. So this is the typical structure of the Soho network. Clear, guys? Okay. So now, almost done. Now, what if we have another or big companies? We have big companies. Suppose the company is having 1,000 PCs. The company is having 1,000 PCs. If the company is having 1,000 PCs, then these PCs will be connected, not all the 1,000 PCs, some PCs will be connected to a switch here. And these switches are called access layer switches. It's called access layer switches. Then from the access layer, so some machines will be connected to this switch called A40 switch. Some machines will be connected to this A39 switch. Some machine will be connected to this A2 switch. Then from the access switch or this access layer switch, then we'll connect it to the distribution layer switches. We'll connect it to the distribution layer switch. And from the distribution layer switches, we'll connect it to the routers. And from the routers, we'll connect it to the external world. Okay, so this is the hierarchy or this is the architecture here in the company level, and it is called two-tier architecture. It's called two-tier architecture, where you have 2 layers of switches here. You got 2 layers of switches. Clear? Last thing for today, 3-tier architecture. 3-tier architecture. If you have multiple buildings and all, right? So if you have multiple buildings and say each building has got multiple machines here like this. So these machines will be first connected to the access layer switches. Okay. From the access layer switch, it is then connected to the distribution layer switches. From the distribution layer switch, it is then connected to another layer called core layer switches. It's connected to core layer switches. And from the core layer, then it is connected to the router and then to the external world. Clear? So this is the 3-tier architecture, means we have 3 layers of switches. The first is the access layer switch, then the distribution layer switch, then the core layer switch. Clear? Okay. So this is, and guys, tomorrow, just remind me to teach, start with spine leaf architecture as well. Okay, spine leaf architecture, which is similar to this one itself, but not normally used. As I told you, this will be the last topic. I'm just winding it up. Okay. Yes. So shall we wind up the class then? Okay. So today we'll wind up the class. Okay. Yes.